In this lesson, we'll be going over how to draw Lewis structures of ionic compounds. Jumping right into it, let's try and draw the Lewis structure of calcium oxide. Let's go one step at a time. We know that calcium oxide is an ionic compound, meaning that it is made up of two ions, a cation and an anion, which are the calcium and oxygen respectively. In a calcium atom, there are 20 electrons. Let's visualize this in a simple Bohr-Rutherford diagram. We have 2 on the first orbit, 3, 4, 5, 6, 7, 8, 9, 10 on the second orbit, then on the third one, 11, 12, 13, 14, 15, 16, 17, 18, and then on the last orbit, 19 and 20. These last 2 electrons are called the valence electrons because they're on the outermost shell of the atom. When we draw Lewis structures, we only draw the atom with the valence electrons, so we can forget everything on the inside. So we end up with calcium with these 2 electrons. Let's do the same for oxygen. It has 2 electrons on its first ring, and then 1, 2, 3, 4, 5, 6 on its second. For its Lewis structure, it only has 6 electrons, and once again we can forget about anything on the inside. And now to turn these atoms into ions, we of course need to give them charges. The way we do this is we transfer the electrons from the calcium to the oxygen. Cations or metals give away electrons and they gain positive charges. So the calcium will have square brackets around it showing that it's an ion as well as a 2+ charge, seeing as it got rid of 2 negative electrons. And now this anion nonmetal, oxygen, has a full valence shell, but this also makes it an ion, so we put square brackets as well as its charge of 2 negative, seeing as it gained 2 negative electrons. As we know, opposites attract, so the positive charge is attracted to the negative charge, and so these electrostatic attractions allow these 2 ions to be tightly packed together. The most important thing to note is that the calcium has a positive 2 charge while the oxygen has a negative 2 charge, meaning that it balances out to 0, hence why calcium oxide is a stable compound. And so the Lewis structure for calcium oxide is the calcium ion with a positive 2 charge and the oxygen ion with a negative 2 charge. Let's move on to another question. Here we have aluminum oxide. To save us a few steps, unlike the last question, in which we figured out the ionic charge by drawing out the atom, finding how many electrons are in its valence shell, and doing the transfer of electrons, we can actually take a look at the element in the periodic table and find its charge. And we can see that aluminum has a positive 3 charge, meaning that it will get rid of 3 electrons, showing that it is a cation like other metals. Now remembering from last time, the oxygen ion should have a full valence shell with a negative 2 charge, which we can clearly see on the periodic table. It does indeed say a negative 2 charge, and so we're finished now, right? Well, we have one little mistake. You see, the charge on this compound is not balanced, seeing as the net charge from the aluminum and oxygen is a +1 charge, which can only mean one thing. We need to add more ions. How many exactly? Well, we can just take a look at the chemical formula, which tells us exactly how many we need. It says we need 2 aluminum ions and 3 oxygen ions. If we draw the atoms in Lewis structure format, with all the electrons before they've been transferred, we get this. Let's see what happens when we transfer the electrons from these 2 aluminum atoms to the oxygen atoms. First, these 2 go here, making the oxygen an ion. This last electron, along with this first electron from this aluminum, going to the second oxygen, makes this aluminum an ion, and this oxygen another ion. And then finally, if we transfer these last 2 aluminum electrons to this last oxygen atom, we can form another aluminum ion and another oxygen ion. and adding all this up, we get a positive 6 charge as well as a negative 6 charge, meaning that this aluminum to oxygen ion ratio is correct. So we know how many of each ion we need, but how would we arrange them and why? Well, to do that, we need to take a look at the ionic compound structure, which is also known as the crystal lattice. You see, in solids, there lie ionic compounds made up of cations and anions that have really strong electrostatic attractions to each other. To optimize these attractions, the cations and anions are uniformly arranged in a way that each ion is surrounded by an ion of the opposite charge. This is what keeps solids together, and it is what sets solids apart from gases and liquids that do not use the attractions of ionic compounds, but rather intermolecular forces of molecules, which are not as strong, hence why there exist liquids and gases. Anyways, back to the Lewis structure of aluminum oxide. Since we know that ionic compounds have a crystal lattice structure in which there is a uniform arrangement of the ions, then when we draw the Lewis structure, we should follow this trend. We can move these two over and add another oxygen ion, making it so that the aluminum is surrounded by ions of opposite charge to maximize the attractions. And we will put the remaining two being the aluminum as well as the oxygen ion. And just like that, we've solved it. Here are a few more examples that are the exact same from the questions that we just did. If you're able to easily do these questions, then I'd say you're good with the lesson. First, potassium sulfide, that is K2S, and we know that that means we need 2 potassiums as well as 1 sulfur. Potassium is a cation that has a positive 1 charge, and since there are 2 of them and only 1 sulfur, that means that those 2 electrons will go to the sulfur, forming the 3 ions. And so it will be potassium ion, sulfur ion, and then another potassium ion. And as you can see, the sulfur has a full valence shell, full octet, and the charge is completely balanced. Next, barium phosphide, which would be Ba3P2, meaning that we need 3 bariums and 2 phosphorus ions. And taking a look at the periodic table, barium has a positive 2 charge, and phosphorus has a negative 3 charge. So drawing out the ions barium, phosphide, barium, while also checking to see if the charges balance, and it looks to be good. And then finally we have sodium carbide, which is Na4C. We'll have to draw this one a little bit differently, but still it's the same idea. In the middle we will have the carbon, which requires 4 electrons to have a full octet. And thankfully there are 4 sodium atoms that have an electron they're willing to spare. And so this gives us a carbon ion with a negative 4 charge surrounded by 4 positive sodium ions. Everything is balanced, so everything seems to be good. If you've made it this far into the video, chances are you're learning a lot and enjoy the content. So if you don't mind, consider subscribing, as it shows me that you like what you see, which helps me post more videos. Anyways, that's all for now. I hope you have a wonderful day.